that the ethical issues in computational social science are very important. They're very important for practical reasons and for philosophical reasons. And my experience has been that when I talk about these things, sometimes people don't pay attention. They turn themselves off. They're like, oh, I don't want to talk about ethics. So, not that people want to be unethical, they just don't want to deal with it. So, one of the things that I try to do sometimes is think about ways of expressing it in a way that makes it seem not like the same ethical conversation we've had many times before. And so I think one way to do that is potentially to not think about ethics in human studies at all. Let's forget about humans for a second, and let's think about animals. Okay, so kittens, everyone likes kittens. As you know, I like kittens. So let's imagine we were going to do some experiments with kittens. Not like a survey experiment, like a real experiment, like a biological experiment. So I don't know what people's ethical systems are, but many people would we could imagine experiments that we think are ethically inappropriate on kittens. Like if there's not appropriate safeguards, if there's not valuable information that's going to come from it, there are certain things you just wouldn't want people doing. And there are probably also situations where, yeah, we think it's permissible ethically if you do certain things to use kittens in scientific research, right? So if we think that it's okay in some situations and not okay in other situations, then we have to think about how do we decide which is permissible and which is impermissible. And so people that do research with animals, there's obviously a lot of research done not just with kittens, but with rats and mice. More research with mice than rats. They're not the same thing. Monkeys, all kinds of things happen. And so they have this idea of humane experimental techniques. This is a classic work from this field from 1959. And they have these 3 R's, replace, refine, and reduce. So you want to replace, for them they say replace, you want to use, like, you rather use like cats or dogs rather than monkeys, and you'd rather use mice rather than cats or dogs. So they have some way of like ordering organisms that I don't totally understand, that you want to like use like less human-like organisms, kind of. You should read the book. They have a much better explanation of that. You want to refine your treatments to be minimally harmful. Like you don't want to harm the kitten in an unnecessary way. You want it to be the least harmful possible, and you want to reduce the number of kittens you're using. So you don't want to put in 10 times as many kittens as you need into your experiment. That would be bad, right? Okay. So now I want to argue that we can use these 3 R's to think about humans again. Now we're going to switch back to humans, but we have kind of a different framing to think about it. So replace, and we're going to try to illustrate these 3 R's with this study that you all know very well, I believe. This is the emotional contagion experiment. So this is a study that generated a lot of ethical controversy. I think there are a lot of complicated issues. I deal with a lot of them in the book. I'm picking this as an example, not to second guess the decisions that they made, but to illustrate that these 3 R's are very practical and realistic studies. I think we all agree this is a realistic study. This is a study that generated intense debate, and the 3 R's suggest concrete, real things that they could do that might have improved the ethical balance of the study. So basically, again, they randomly blocked positive posts from some people's news feeds. They randomly blocked negative posts from other people's news feeds. They had control conditions, and they measured the effect on the words that people subsequently posted. This was a large field experiment, 700,000 people. The people did not give consent beyond the basic terms of service that they provided to Facebook. And there's a lot more details about the experiment that's in the book. So that's just a refresher. So then there was this, as you all know, there was a lot of debate about it. PNAS published an editorial expression of concern, which is pretty unusual. So let's think about what the 3 R's could mean very concretely for a very real study. So replace, so I think we can say replace experiments with less invasive methods. And so we can replace experiments with natural experiments. So this is a paper, detecting emotional contagion in massive social networks, that used, rather than Facebook intervening and making people's feeds more sad, what this does is it says, oh, rain happens randomly, and if it's, let's say you have some friends who live in Dallas, if it's raining in Dallas, people post more sad words, so your feed is going to be randomly sadder on days when it's raining in Dallas. That's kind of the rough idea. So this is a natural experiment. So you don't have to actually deliver the treatment, the world delivers the treatment for you. So obviously there are clear trade-offs between natural experiments and designed experiments. There are certain things you can do in designed experiments you can't do in natural experiments. But you would have to ask yourself whether in certain situations, whether the knowledge, there are certain experiments that we would like to do that we can't do, right? And in those situations, we look to replace experiments with less invasive methods. And I think the case in the audit studies of discrimination, a key part of this is that this is hard to do using any other thing, right? And so if they could have made the case that this is the only way to get this knowledge, then they would have been in a stronger position. And in fact, there is this alternative technique that one of the authors was a part of. Adam Kramer was an author of both of these papers.
Oh, of the raining in Dallas one?
Yes.
Did it have the same outcome?
It's very complicated to tell because the way they analyze the data in this paper is a little bit of a non-traditional way of doing an instrumental variable thing, and we will have the rest of that conversation offline.
Right.
But I think it's very hard to compare them. But the general point is sometimes you don't have to do an experiment. Sometimes there are other techniques that you can use. Refine the treatments to make them less harmful. So generally we don't want to do anything that's more harmful than we need. So the argument here is for the emotional contagion. One of the things that people didn't like is that people could have lost important messages in their newsfeed. And that was because the blocking of the post was completely random. So it could have been something high in your feed that got knocked out. So an alternative design, which the Facebook newsfeed team has used, is boosting. So you just turn up certain kinds of content rather than knocking content out. Instead of blocking, use boosting. And so what boosting would do is it would also change the content of the feed, but the posts that would be displaced would be the posts that were generally at your bottom of your feed, not the posts that were generally at the top of the feed. So a boosting, and it's hard to argue theoretically that you would prefer a blocking design to a boosting design given the theories that they had. It seems like both designs would be equally effective at assessing the theory that they were considering, and a boosting design is less likely to cause people to miss important things. Now, it may be the case that a boosting design was harder to implement given the way the Facebook experimental infrastructure is. That I don't know. My guess is that is why they did the blocking design, but I don't know. So again, all of these things involve, sometimes there's trade-offs, right? So the natural experiment is sometimes not as good as the designed experiment. Certain kinds of treatments might be easier to implement than others. Lastly is reduce the number of participants. So in the same way you don't want to use more kittens than you need, you don't really want to use more participants than you need. And so here, one of the things about a lot of online data systems is that you have a lot of pre-treatment information. And in the analysis, they didn't actually use that pre-treatment information. So if you, instead of comparing a difference in means between these two groups, if you, for each person, calculate the change in positive and negativity, that reduces the variability a lot in your outcome. So imagine you were doing a study, like a weight loss study, and you could compare, so you randomize people, you give them an exercise program, and then you compare their weight at the end. So that comparison is going to be, let's say the effect is small, it's going to be harder to detect because you have a lot of naturally occurring variability in the groups. Now, but the fact is people's weights don't change that much. So if you calculate a change score for each person and compare the change scores, there's much less variability. So you're essentially getting rid of a lot of noise by working with change scores rather than difference in means. So this would allow you to detect a similar size effect with many fewer people. So this is a well-known idea in design of experiments. And in the online setting, this idea is potentially more valuable than in other settings because a lot of outcomes are very skewed. And so there's a lot of variability, and a lot of outcomes are relatively correlated over time. So in those situations, the change score is going to have much less variability than the raw outcome. And so the change score, you're going to be able to detect this difference with fewer people. So we don't know the details of this particular setting. There are other papers, this Deng et al. Paper and this Shi and Arset paper are about online experiments and about improving the efficiency of online experiments. And they estimate that by including this pre-treatment information, you can cut the size of your sample in half. So that would mean instead of 700,000 people, you could have had 350,000 people. Now you may say, well, come on, emotional contagion really wasn't that bad. Why should we care about exposing an extra 350,000 people to the experiment? So I would say we should care under some conditions. So one is whether there's uncertainty about whether the treatment will cause harm. So I think these researchers do not think it will cause harm. I don't know. I think my guess is it probably didn't cause a lot of harm to a lot of people, but I don't really know, to be totally honest. They probably know more because they've worked with that kind of data much more. But I think if there is uncertainty about whether it might cause harm to at least some people, because remember, it's 700,000 people, it's a lot of people. It's not like a small number of people. So rare events happen in big data sets. We talked about that before as a positive thing, right? We were looking for rare populations in big data sets. It applies also in the negative way as well. And then also participation was not really voluntary in this setting in the way that we think about in the sort of research ethics setting. So if you're conscripting people into your experiment, and if there is uncertainty around whether the experiment could cause harm, then you should try to minimize the number of people that you need, I think. That doesn't mean you should never do an experiment like this. It just means you should try to do as few people as possible to achieve the scientific goals that you have. So another way to think about the 3 R's and ethics in general comes from a source of ethical wisdom, Spider-Man. So this is the very first Spider-Man comic book, and this is his Uncle Ben has just died, and he could have saved him, but he didn't. And then he walks away into the night, and it says, with great power there must also come great responsibility. And so if we believe that we now do have the power over people's lives to enroll them in experiments without their consent and without their awareness, that also comes with certain responsibilities. It doesn't mean that we shouldn't do them. It does not mean that, but it means it comes with responsibilities. And so I think thinking about the 3 R's is a way to think about what these responsibilities are. So I think the 3 R's also show that humane methods can be an opportunity because they're potentially more efficient than standard methods. So this is not, so we've talked about, like, remember at the beginning I was saying ethics, think of ethics as a research opportunity. So there are a lot of methodological questions that exist around how do we decide what is a treatment that's minimally harmful? How do we reduce the number of participants in our experiment? These are the kinds of questions that empirical researchers have to ask. These are not the kinds of questions that ethicists can answer, right? Like, ethicists don't know about optimal experimental design. That's the kind of thing that empirical researchers know about. Ethicists know about other things. So I think there's an opportunity to think about building methods that are potentially more humane. And if you are able to develop these methods, these could become things that would be standards that other researchers would use, and then sort of, as Gary King was saying, the bigger the problem you solve, the more citations you get, right? So if you develop a standard way of doing humane experiments on mechanical Turk, let's say, and you convince everyone that your way is more humane than everyone else's, then that would be recognized, I think, as a big contribution. What would that actually look like? I have no idea. I wish I knew. But I think we'll figure it out. And then I think, again, computer science is a good example where you have a bunch of methodological research that's happening that's focused on developing sort of more ethically responsible ways. So differential privacy, I think, is a great example. So very briefly, if you have a database and you want to query that database and return an answer without revealing any information about the person, that's kind of the goal of differential privacy. There's a lot of data. Let's say the hospital here in Princeton, that has a database. There's a lot of valuable information in that database. They obviously can't just let anyone who wants look at that database. So imagine if there was a way that researchers could safely query that database and get an answer such that there was some theoretical guarantee that they would not learn any information about any particular person. So like, let's say you want to know the mean age of people in the hospital, then under relatively general conditions, that's a safe query. So assuming there's enough people in the hospital and assuming a couple of other things, right? That is useful information that's potentially not dangerous to any person. So differential privacy is a whole set of techniques that allow you to make these queries, figuring out what queries are allowable and not allowable, what's the most accurate thing that can be returned while maintaining certain privacy guarantees. Now there are tons and tons of papers about differential privacy. It's a very active area. So I think that is a very concrete example of an active area of methodology that is motivated in part by a kind of ethical concern. So I think there will be some kind of version of this in the social sciences and computational social science. And I don't know what it will be, but we'll have to figure it out. Okay, so I think it is time for lunch, and we can shut off the live stream, and we can have lunch, and we can talk about all these other things that, whatever we want to talk about. All right, so thank you, everyone.